Well, hi there sports fans, and welcome to this first video lesson for Physics 12. This is lesson 1.1, and it concerns itself with motion at constant speed. So we're going to start with a very simple equation which you've probably seen before, which is distance equals speed times time. Now I'm going to rewrite that equation, and I'm going to put some vector signs in there. We'll put a vector sign over top of the D and a vector sign over top of the V. So this now you would say is displacement equals velocity times time. You've probably seen these equations before, and the concepts in this lesson are not that difficult, but they're very important, so you want to make sure that you fully understand them. Now scalar, which is distance is a scalar, and it has magnitude only. We're not concerned about anything else, just the magnitude of that distance. And also speed. Speed is also a scalar, and it has magnitude only. A vector, however, when you put a vector sign in front of or over top of something, then you are concerned with both its magnitude and its direction. Now this may seem like a small difference, and it's only a different way of saying it. However, there are huge implications to this, which we will see later. They can be the same, but they can also be very different things. So the vectors here then would be displacement. Displacement is a vector, and velocity also is a vector. And as I said, quite often distance and displacement, or speed and velocity, are the same, except when you have a change in, and can you guess what that change would be? Well, if you guess direction, you'd be right. When you have a change in direction, distance and displacement are not the same, and speed and velocity also are no longer the same. And so we'll go through an example to demonstrate that. Now I'm going to rearrange these equations here. So we first had distance equals speed times time, and I'm going to move the t over to the other side here. So now we have an expression for speed, and speed is distance over time. By the way, time is not a vector. It's never a vector. It has only magnitude. And here we have the other equation, displacement equals velocity times time. And we'll move the t over here, so we have velocity equals displacement over time. Now, distance is the total distance that you cover. No matter how you get from one point to another, it's the total distance that you cover. Displacement, however, concerns itself only with your starting position and your finishing position. And it's the distance from the start to the finish. Okay, so let's look at an example as to how we can illustrate when they might be the same and when they would be different. So let's first look at going from point A to point B. So if we go from point A to point B, and it's 10 kilometers, and it takes us 2 hours to get there, then let's find out what your speed is for that moving from A to B. So the distance from A to B is 10 kilometers. The time it took was 2 hours. So your speed will be 10 divided by 2, which is 5 kilometers per hour. Right? So you went 5 kilometers per hour for 2 hours to get from A to B. The velocity now, the displacement is the same. There's no change in direction here. So your displacement is also 10 kilometers. So your velocity then will also be 10 divided by 2, which is 5 kilometers per hour. Now, as I mentioned, velocity and vectors, you have to indicate direction. So when you're going from to the right, like here, then we would call that direction east. And so we would indicate that either with just an uppercase E like so, or you could write out the word east. Another way you could write it is this way here. 5 kilometers per hour. And we also use a lowercase I with a little hat on it to indicate direction in the, along the x-axis or parallel to the x-axis. So you probably haven't seen this before, but this is just another way that we use to indicate direction parallel with the x-axis. At another time we'll look at the y-axis. But we actually do use this quite a bit, and it's quite convenient to use this. So this may be a new symbol for you. So let's look at if you're going from A to C now. Let's say we're going from A to C. Well, the total distance that we covered is 15 kilometers because we first went 10 kilometers this way, and then we went 5 kilometers this way. So the total distance that we covered is 15 kilometers. It's now taken us 3 hours, 2 hours this way, 1 hour this way. So therefore our speed then will be 15 divided by 3 now, which is 5 kilometers per hour. 5 kilometers per hour, which is the same as this over here. However, let's look at velocity now. The displacement, if you remember, we said was the distance only from the start to the finish. And the displacement in this case is 5 kilometers. It's not 15, it's just 5. Because the distance from your starting point to your finishing point is just 5 kilometers. So that's going to change things. So your velocity now will be 5 divided by 3. And if you round it to 1 decimal place, that will be 1.7 kilometers per hour. Whole lot different from speed now and distance. We also have to indicate our direction here. So we would use, again, our little I, or we could say it's 1.7 kilometers per hour east. Okay, either way, and again, just try to get used to using this symbol right here because we do use it quite often. So you can see when you have a change in direction, that's going to change things as far as displacement and velocity. Now there's one other concept in this lesson which is what's referred to as relative velocity. And if you have two objects that are in motion, then you can say, then you can refer to the velocity of one with respect to the other. And if your objects are moving in the same direction, so let's say A is moving that way to the right, and let's say B is also moving to the right, like so, then they're moving in the same direction, so the speed of A relative to B, you would subtract. You would subtract the speed of B from the speed of A. So you would subtract their speeds. So if their directions are the same, you subtract. And if their directions of travel are in the opposite direction, so let's say object B now is moving toward A, then you would add their velocities together. So you would add them together. So that's relative velocities in a nutshell. And I will go over a couple of examples of that in class with you. And then we will move on from there.